Easy. Ferretic. It is nothing but hot springs and geysers. हाँ, वेव जब आती है तो it deposits the various sediments. If the sediment is deposited in the form, if this is how the sediment is deposited, this is what is known as sand spit in longitudinally. If the sediments are deposited in a tongue shaped manner, it is known as tombol. Plate boundaries, tricellular, काफी easy paper है इस time. Ferritic is nothing but when volcano or magma heats up. हाँ, ferritic नहीं लिख पाएंगे बच्चे, that is also for very sure. Heats up groundwater to give rise to concept is very easy. The only thing is you should know the word ferritic. टम्बोलो सब लैंडफॉर्म्स का पार्ट है, बहुत आसान है. मीन्स क्लाइमेटोलॉजी से इट इज ट्राइसेलुलर, राइट. वेबर से इट इज आइसोडोपेन, डायरेक्ट क्वेश्चन. ग्रोथ पोल थियरी, डायरेक्ट क्वेश्चन. सो द एज कंपेयर टू लास्ट ईयर से भी इजी है आई गेस. सेक्शन बी अभी लिख रहे हैं स्टूडेंट्स, वेरी इजी, वेरी इजी एक्सेप्ट फॉर फेरेटिक, बाकी सब डायरेक्ट है. मतलब हम इतना स्टेबिलिटी इंस्टेबिलिटी पढ़ रहे हैं, नथिंग इज देयर. ट्राइसेलुलर मेरिडोनियल सर्कुलेशन. नेक्स्ट ईयर सच, लास्ट ईयर पेपर वॉज ईजी, सो ऐसा लग रहा था इस ईयर. दिस ईयर ऑल द ऑप्शनल्स आर ईजी. पॉल साइंस इज ऑल्सो ईजी. सब मतलब कट ऑफ थोड़ा हाई जाएगा. पॉल साइंस का भी मैं पेपर देख रहा था, उसमें भी शॉर्ट नोट में एक ऐसा शॉर्ट नोट है जो नहीं लिख पाएंगे जैसे फेरेटिक है. सो दे ट्राई टू बैलेंस इट. सेक्शन बी में से 2 क्वेश्चंस तो आराम से उठ जाएंगे. दे आर वेरी वेरी इजी. ग्रोथ पोल इज डायरेक्ट. आइसोडोपेंस एंड आइसोटिम्स इज डायरेक्ट क्वेश्चन. इफ यू रिमेंबर जीएस में, जो अटेंड जीएस, आई मेक दिस डायग्राम and then industrial location triangle we make. This line is what is isodopen. But I had not included in your handout का notes the coastal landforms. मुझे नहीं लगा था वो पूछेंगे. They have asked, so I will give you the टम्बोलो. सब direct है वो questions. They are nothing but coastal landforms. टम्बोलो is given even in Gisilio. So coming to the instability, there are 3 kinds of instability when we say. One is the, so what is stability? Tell me. When DALR is greater than NLR. What is absolute stability? When wet adiabatic lapse rate is greater than normal lapse rate. What is instability? Less. And absolute instability. What is mechanical instability? जब the normal lapse rate is much greater than dry or wet adiabatic lapse rate. That is in the formation of tornado. Getting it? What is the absolute instability? And now with this is conditional instability. Conditional instability means in certain conditions there will be instability, in certain conditions there can be a stability. Potential evaporation मैंने उस दिन आपको बहुत short में बताया how Thornwright calculates it, वही question आया था regarding the potential evaporation. So we will come obviously in the potential evaporation while coming to Thornwright. That is a difficult question, that is not an easy question कि how the potential evaporation has been calculated by the हाँ potential evaporation favorite है उनका. The only thing is Thornwright coupon हर साल आता है. The only thing is Davis Penk comes every year. This year there has been no Davis, no Penk. Means they have asked you GS ka question, how many types of plate boundaries are there? Convergent plate boundary, divergent plate boundary and transform plate boundary. So conditional instability. When the parcel of air is forced to move upwards, it may cool at both dry adiabatic lapse rate or wet adiabatic lapse rate. It may cool at any rate. So it may cool at dry adiabatic lapse rate, it may cool at wet adiabatic lapse rate, or it may cool at, and there will be normal lapse rate. So initially take a condition, initially it cools at the dry adiabatic lapse rate, that is 10 degrees Celsius for every kilometer. Then after that it becomes saturated. The moisture is added to it, and then it will cool slowly with the help of wet adiabatic lapse rate, that is the 5 degrees Celsius per kilometer. And we will take the normal lapse rate as 6.5 degrees Celsius per kilometer. So again we will take this condition, 1 kilometer, 2 kilometers, 3 kilometers, 0 kilometer, 30 degrees, 23.5 degrees, 18 degrees, right? Then 11.5 degrees, or sorry, it is 12.5 degrees, जो कुछ है, 6, that is it goes on decreasing at the rate of 6.5 degrees Celsius. The parcel of air A, it is rising upwards, 30 degrees is the ground surface. It reaches up to this height, and after reaching this, after this height, it will now become saturated. So it is cooling, we'll take for example, it reaches this height. It is becoming saturated at this height. So यहाँ तक it is cooling at the dry adiabatic lapse rate, which is 10 degrees Celsius. So यहाँ पे उसका temperature is 20 degrees Celsius. Is it cooler than the surrounding air? Yes. But in spite of being cooler than the surrounding air, it will start rising upwards, and it will now cool at moist adiabatic lapse rate. So यहाँ पे उसका temperature becomes 15 degrees Celsius, but still it will keep on rising upwards. यहाँ पे उसका temperature becomes 10 degrees Celsius. After 4 kilometers, the temperature becomes of the atmosphere is 6.5 degrees Celsius. The temperature of air is 5 degrees Celsius. It will still rise upwards. The temperature of the atmosphere becomes 0 degrees Celsius. The temperature of this parcel of air becomes कितना? What? कहाँ पे? कैसे इक्वल हो जाएगा? 30, 20, 15, 10, 5. 30 minus 6.5. 6.5 minus 18 minus 6.5. 11.5. -6.5 कितना हुआ? अच्छा 5 डिग्री सेल्सियस. So चलो it becomes 5 degree Celsius. It has become equal. This air will still go upwards. यहाँ पे the temperature of the atmosphere becomes -1.5 degree Celsius. यहाँ पे the temperature of the air becomes 0 degree Celsius. Now is it becoming warmer than the surrounding air? पहले it was cooler than the surrounding air. Now it becomes warmer than the surrounding air, and warmer than the surrounding air, obviously it will rise upwards. Getting it? It will keep on rising upwards. So initially the air which should have been stable and should have come down continues to rise upwards, and after reaching a certain height it becomes warmer than the surrounding air, and this is what is known as a conditional instability. Why is this air in the normal condition which should come down is now rising upwards? Uska reason is because यहाँ पे there is a mountain barrier. Had there been no mountain barrier, यहाँ पे stability हो जाती. This air would have come down. What is stability? Cooler than the surrounding. So this condition is fulfilled here, but no, the air will be rising upwards. Air will be rising upwards. Air will be rising upwards. The mountain barrier will not allow the air to come down. It will keep on rising upwards because पीछे से wind चल रही है. So initially there is a stability, but the air is forced to rise upwards due to a mountain barrier, and then after reaching certain height, this air becomes warmer than the surrounding air, and it continues then its upward journey. This kind of instability is known as conditional instability. There is some kind of a condition. What is the condition? Some kind of a physical barrier. Remember this? Stability, instability. So this is what is the conditional instability. So what is the conditional instability? Initially it cools at dry adiabatic lapse rate, and then it starts cooling at wet adiabatic. Dry adiabatic lapse rate 10 degrees Celsius. So can I conclude, we will write in proper manner, can I conclude conditional instability is when dry adiabatic lapse rate is greater than normal lapse rate, but wet adiabatic lapse rate is lesser than normal lapse rate. This is what is the conditional instability. Clear? Getting it? Or not? नहीं, ज़रूरी है. ज़रूरी इसलिए है क्योंकि अगर नॉर्मल लैप्स रेट ज़्यादा है वेट एडियाबैटिक लैप्स, ड्राई एडियाबैटिक लैप्स रेट से, if it is 11.5 degrees Celsius and dry adiabatic lapse rate is 10 degrees Celsius, and we say normal lapse rate is greater than dry adiabatic lapse rate, what you are saying is this, right? Then also the air will continue to rise upwards. This is your doubt? So it will not be conditional instability, it will be instability. Understanding? What is instability? Normal lapse rate is greater than dry adiabatic lapse rate. What is absolute instability? Normal lapse rate is greater than moist adiabatic lapse rate. What is conditional instability? ये एक अलग situation है. The air which should have been stable will continue to rise upwards. Why? In spite of it not following this. In spite of it not following this. This is what is the kind. ये तो instability हो गई. फिर वो तो rise ही करेगी upwards. And why we have to study separately? What? Five. तो लेस देन है ना. तो लेसर ही है ना ये साइन। अच्छा अच्छा, दिस इज द साइन ऑफ लेस देन। हाँ तो लेस देन ही तो है। तो 6.5 is lesser than 5। ये एक इक्वेशन मैंने एक इक्वेशन में बनाया इसलिए ये कंफ्यूजन है। ऑब्वियसली लिखते समय ऐसे नहीं लिखेंगे हम। सो सेपरेटली सेपरेटली कंसिडर करो। ये तो मैंने आपको समझाने के लिए इतना रफ में लिख दिया है ये। अच्छा मूव वो अलग अलग पैराग्राफ में आएगा ना, मूव मूव की बात। So that is what I tell कि don't go by this statement. This is just for you to understand. Have you understood that DALR is greater than WLR is greater than NLR in the first condition? NLR is greater than WLR. Have you understood this? That is what is the conditional instability. This is very rough. Very quickly I made you understand the three things. What is conditional instability? DALR is more than normal lapse rate, and normal lapse rate is more than wet adiabatic lapse rate. I got your problem, but ये मेरे को लिखना नहीं था इतना लंबा, इसलिए मैंने जल्दी जल्दी में वो समझाने के लिए लिख दिया। ठीक है? हाँ, yeah, symbol is wrong obviously. But have you understood the crux? So next is the, where did we stop? It may cool at dry or wet adiabatic lapse rate. Next, air parcel initially cools. Air parcel initially cools at dry adiabatic lapse rate of around 10 degrees Celsius per kilometer, of around 10 degrees Celsius per kilometer, where the normal lapse rate of the air normal lapse rate of the air is around 6.5 degrees Celsius, full stop. When the air parcel reaches a certain height, when the air parcel reaches a certain height, it becomes saturated. Underline the word saturated. Initially the air was dry, it becomes saturated. And latent heat of condensation is added to it. Latent heat of condensation is added to it. Latent heat of condensation is added to it. Therefore, it becomes warmer than the surrounding air. Therefore, it becomes warmer than the surrounding air. Why? Because latent heat is added to it, right? Warmer than the surrounding air. And this warm air then will continue rising upwards. this warm air then will continue rising upwards and become unstable Understood? Become unstable. Thus, the conditional instability occurs. The conditional instability occurs when the normal lapse rate, is between dry and wet adiabatic lapse rates. Is between dry and wet adiabatic lapse rate. It is known as conditional instability because strong initial uplift of the air, in the bracket may be due to orographic barrier, or convective uplift, is the prerequisite condition, for such instability, Conditional instability is the most common type of instability. Conditional instability is the most common type of instability. As most of the air mass after reaching a certain height become warmer due to the addition of latent heat of condensation, and then continue their upwards journey. Without any impulse. Further help or impulse. So initially there is an orographic barrier to help it, and later on there is no impulse to help it. Understanding this? अंडरस्टैंड दिस डायग्राम। रेड कलर का लाइन इज नॉर्मल लैप्स रेट, यूनिफॉर्म है। ब्लैक कलर का नीचे का लाइन इज ड्राई एडियाबैटिक लैप्स रेट, जो ज़्यादा ग्रेटर है, इसलिए द एयर इज कूलिंग मोर विथ मोर हाइट, बट आफ्टर रीचिंग अ सर्टन हाइट इट स्टार्ट्स कूलिंग विथ initially with dry adiabatic lapse rate and then with wet adiabatic lapse rate, which is lesser, around 5.5 to 5 degrees Celsius, and then it starts cooling with that height, and इसलिए यहाँ से हो गया conditional instability. Getting this diagram, graph? एंड ये जो 1500 to 1000 मीटर्स क्या है, द एरिया जहाँ पे उन दोनों का टेम्परेचर इक्वल हो गया था, दैट इज द, जो मैंने स्टार्टिंग में आपको सिंप्लीफिकेशन में जो पार्सल ऑफ एयर का जो डायग्राम बनाया था, it will become condensed here. As soon as it becomes condensed, it is now starting to get warmer because latent heat is getting added. So यहाँ से ग्राफ चेंज हो रहा है, उसके बाद इस लेवल के बाद वो वार्म हो गया एज कम्पेयर टू द सराउंडिंग एयर, एंड वो खुद ऊपर जाएगा, इट विल गो ऑन अप ऑन इट्स ओन, देयरफॉर वी कॉल दिस नाउ एज अ कन्वेक्शन लेवल, कन्वेक्शन लेवल, कंडेंसेशन लेवल. Understood this? So यहाँ पे वो डायग्राम नहीं फिक्स चलेगा because then it will become too tedious. Initially 30 degrees, parcel of air is also 30 degrees. It will cool. यहाँ पे उसका 20 degrees होगा. यहाँ पे the environment will be 23.5 degrees Celsius. Still it will go up. It should come down stability, but यहाँ पे there is a mountain barrier, so it still keeps on going upwards. After certain height उन दोनों का temperature becomes equal. Then after certain height इसका temperature होता है 0 degree, -5 डिग्री सेल्सियस, बट यहाँ का टेम्परेचर होगा -6.5 डिग्री सेल्सियस. So this air will become warmer than the surrounding air. इसी लाइन को हमने यहाँ पे दिखाया है as convection level. Getting it? Those who came late, starting के 5 मिनट देखो आप, you will understand what is this. Can I continue? So these are the types of instability. Next, conclusion. Rosby has made an extensive study. Rosby has made an extensive study of the types of the instabilities. Rosby has made an extensive study of the types of the instabilities and has come to a conclusion that different aspects of convection will give rise to different levels of instabilities. Which will cause variation in the percentages, which will cause variation in the weather phenomena and precipitation, not percentages, which will cause variation in the weather phenomena and precipitation. The relationship between normal lapse rate dry adiabatic lapse rate, retarded lapse rate. Retarded means moist adiabatic lapse rate is as shown below. You can draw the diagram. Let this diagram come in the conclusion part. इसमें से कौन सी लाइन होगी मॉइस्ट एडियाबैटिक लैप्स रेट, कौन सी लाइन होगी ड्राई एडियाबैटिक लैप्स रेट, कौन सी लाइन होगी नॉर्मल लैप्स रेट? लाइन 1, लाइन 2, लाइन 3. Which is normal lapse rate? Line 2. Which is dry adiabatic lapse rate? Line 1. Why line 1? That is why I have shown you. वैसे डायग्राम में बनाने की जरूरत नहीं. 0 to 20 degree Celsius का difference है. This you can see the rate of decrease is very fast here with the increasing height. So that means it is dry adiabatic lapse rate. The rate of decrease of temperature is very slow here. That means it is moist adiabatic lapse rate. And which is in between in the most of the conditions is the normal lapse rate. It is not below, na? It is the rate of change of temperature with increasing height. On the y-axis it is height, on the x-axis it is temperature. Where is the rate of decrease of temperature faster? This line or that line? You can see this is slowly decreasing, this is quickly decreasing. So, quickly decreasing means it has to be greater. Which is greater? Dry adiabatic lapse rate is greater. Not understanding? Now understanding? It is quickly cooling. At the height of 500 meters, this is more cooler as compared to this, as compared to this. यहाँ पे the temperature at the height of 500 meters is somewhere between 20 to 15 degrees Celsius. यहाँ पे the temperature at the height of 500 meters is between 15 to 10 degrees Celsius. यहाँ पे the temperature at the height of 500 meters is less than 10 degrees Celsius. Means where the rate of cooling is greater? In the line, this line. Therefore, it is dry adiabatic lapse rate. This is wet adiabatic lapse rate. इसलिए the rate of cooling is lesser. बीच में is the normal lapse rate. Understood? Why these three lines are there? Can I rub this? See, it is a normal graph. Tell me, have you understood the graph? What is that? Why that line is called as table? Why is that stable? Why it is written? उस ऐसा क्यों दिखाया हमने? Why बीच में की line is instability? Why this line is stability? Have you understood this? It is not that easy. देखो, this is the average value of normal lapse rate, but the normal lapse rate keeps on varying. If the dry adiabatic lapse rate is always greater than the normal lapse rate, wet adiabatic lapse rate is also greater than the normal lapse rate, then it is known as stable. If the dry adiabatic lapse rate and the wet adiabatic lapse rate are lesser than the normal lapse rate, it is known as unstable. If they are in between, then it is known as conditional stability. That is what this diagram says. This is a diagram of Rossby, the one who discovered the jet streams. वो diagram इतने simple कैसे हो सकता है? This is a dynamic diagram कि ये keep करेगा, vary करेगा. Understanding? अगर नहीं भी समझ में आया तो you have to just remember, इस साइड आप लिखोगे stability, because normal lapse rate से दोनों rates ज़्यादा है. इस साइड लिखोगे instability, because normal lapse rate से दोनों rate कम है, and बीच में आप लिखोगे conditional instability. This diagram is value addition. If you want to make it, make it. If you don't make it, don't make it. Fine? Stability and instability. Next point, stability and instability is largely controlled by daily weather phenomena. So, stability and instability largely controls, is nahi, largely controls the daily weather phenomena. Daily weather phenomena. Convection, fronts, orographic barriers, promote stability, while temperature inversion, anticyclonic conditions promote instability, horizontal motion of the air in the form of winds, stability. क्या लिखा है मैंने? Stability. Anticyclonic conditions, temperature inversion, stability. Next. Horizontal movement of the winds. Horizontal movement of the winds. Horizontal movement of the air also causes changes in the stability and instability. Also causes changes in the stability and instability. Because एक बार मनु को भेजना, मनु को, because cold winds bring stable air masses, while the warm winds promotes convection and instability. Warm winds promotes convection and instability. Getting it? Ab secondary winds. We come to now easy topics. Till the time we come to Thornwright and Koppen, ये पूरा easy है. That is the secondary winds. And secondary winds में there is one wind, that is the monsoon winds. Give me 2 minutes till the time ये template में निकाल देता हूँ. मुझे नहीं पता किसमें. See, what is a monsoon wind? सबसे पहले, what is the basic idea of monsoon? You only tell me, Bal. What is the basic idea of monsoon? Reversal of winds. Why? Because of ITCZ. Next point. Monsoon क्या है? Equatorial westerlies. एक दो पॉइंट मॉनसून के बारे में जो भी पता है वो. शिफ्टिंग ऑफ प्रेशर बेल्ट्स, we have finished geography now in GS. So what is monsoon? Onshore, offshore, southwest. What is monsoon? दूसरा कोई point? You. Northeast monsoon, no rain. Next point, monsoon में और क्या क्या factors हैं? क्यों? जेट स्ट्रीम है कि नहीं? रिवर्सल हो गया है. कुछ नया पॉइंट. मैस्केरिनीज हाई, मैडागास्कर हाई, टिबेटियन प्लाटू, अल नीनो, ला नीना. So what is basically, I'll quickly tell you what is monsoon. During the summer season, यहाँ पे there is, on India there is a low pressure belt. Wind always flows from low pressure to high pressure. As surrounding ocean is at a high pressure. And therefore this wind come from high pressure to low pressure. Due to the shape of India, they are bifurcated into two branches. One becomes the Arabian Sea branch, the other becomes the Bay of Bengal branch. After this Bay of Bengal branch comes, hits northeast, Arakan-Yoma mountains of Myanmar do not allow them to pass. They are deflected to the northeast. And then सबसे ज़्यादा गर्मी कहाँ पे है? In Rajasthan, in Punjab, in Haryana, in Delhi. So this wind is attracted towards the low pressure and it enters India. And ye because it is onshore wind, it is more like an onshore wind. It is coming from sea to the land. It is bringing the moisture and it is giving the rainfall. During this condition, there is one more wind, but in the upper atmosphere, which is blowing over India, and this is what is known as the easterly jet stream. This is what is known as an easterly jet stream. There is another, the presence of a low pressure belt which is known as ITCZ. It is present somewhere over India here. So the green color line is the ITCZ, which is India ke upar low pressure belt. The surface winds are black color lines in the form of southwest monsoon winds, and they have two branches, the Bay of Bengal branch and the Arabian Sea branch, and the blue color line is the upper air circulation in the form of easterly jet stream. जो easterly jet stream, when it is moving from east to west, it drags. Drags means it pulls. आज ही आया है waves के ऊपर question. So wave oscillation. Wave oscillation क्या था? कुछ नहीं, जो simple words में मैंने बताया था, that is the winds will pull the waves and throw the waves away. So there is a dragging effect of the jet streams because they are moving with a very high speed, and surface winds को अपनी direction में ले जाती है. They move the surface winds to their side, and thus India gets the rainfall. This is what is the summer season, which has gone from the month of June to September end, and we will call, or mid of September, we will call this as the southwest monsoon season, the season that has just gone by. Fine. After that comes the retreating monsoon. I will not spend the time on the retreating monsoon right now, but then in the coming months, as the sun is going to go to the southern hemisphere, there will be cold climate here, and because of extremely cold climate, there will be development of extremely cold conditions here. We will call them as the high pressure due to snowfall and winters coming over India. Southern hemisphere will be at the low pressure. Arabian Sea will be more warmer as compared to the land, because land takes time to get heated, water takes time to get heated and cooled, land will get cooled very fast. As a result of this, abhi sun kahan pe hai? Southern hemisphere mein. So the ITCZ will be somewhere over Australia. Getting it? The ITCZ is somewhere in the southern hemisphere. We are not concerned. Therefore, the surface winds will start moving from the high pressure to the low pressure, and due to the Coriolis force, they will get deflected to the right hand side, and as they are coming towards from the land, they are dry winds, जिसको हम कहेंगे as the northeast monsoon winds, except some winds, they will pass over Bay of Bengal, pick up some moisture, and they will give rainfall to Chennai region या Tamil Nadu region. Otherwise, entire India will be dry. As the ITCZ is to the south now, ऊपर at the top, there will be, just like blue line, there will be another circulation which will come towards India in the form of subtropical westerly jet stream. But unlike the one single blue line, there are two branches of the subtropical westerly jet stream. One is to the north of the Himalayas, the other is to the south of the Himalayas. The one which is to the south of the Himalayas disappears when the green color ka line, that is the ITCZ, shifts over India. The one which is to the north of the Himalayas is still present when during the southwest monsoon wind. But we are not concerned with that line. We are concerned with what is over India. So can I say the southern branch of the subtropical westerly jet stream disappears over India during the monsoon season, right? And it is replaced by easterly jet stream, getting it? And with the coming up of the winter season, dry winds blow from high pressure, that is from the Himalayas, in the form of northeast monsoon winds, and the jet stream is in the form of subtropical westerly jet stream, जो Mediterranean Sea से फिर moisture सब ले आएगी और यहाँ पे rainfall देगी in the form of western disturbances, and it will also give the snowfall. This is what is the monsoon in crux. El Nino was a factor say of the monsoon. They are not that important role in the monsoon. But what plays the most important role in the monsoon is the surface winds, pressure and temperature conditions on the land, and upper air circulation in the form of jet stream. And this upper air circulation in the form of jet stream is due to Himalayas. Due to the height of the Himalayas, the jet stream is bifurcated into two parts. Due to the height of the Himalayas, the jet stream is heated. The red color का jet stream is heated during the summer season, जिसको हम कहते हैं the heating of the Tibetan plateau. Then it rises up from here. So it goes up. Then it tries to go towards the equator. This entire part is the Tibetan plateau. Remember, यहाँ से wind is going upwards. It is going towards the equator. But because of the geostrophic wind ka effect, it gets deflected to the right and it becomes easterly jet stream. Then it goes and settles over Madagascar and Madagascar High. Then it flows from surface towards India, that is Somali jet. Understanding? So what I have told you in detail is today's understanding of monsoon, but this was not the case, and therefore in optional we are going to study 3 different theories of the monsoon: jet stream theory, thermal heating theory, and the recent theory of the monsoon. Understanding? Getting it? So what is monsoon? Is the wind. Monsoon means any wind in which there is 180-degree reversal in the direction from southwest to northeast. India being having a unique climate, there is not just 180-degree reversal in this direction of the surface winds, there is also 180-degree reversal in the direction of upper air circulation in the form of jet streams. Getting it? So therefore we say India has a monsoon type of climate, means our country faces a climate in which the surface winds undergo 180-degree changes in the direction. Before I progress further, let us look at all the kind of the questions that they ask from the monsoon, so that you get an idea of the kind of the questions they ask. Fine? And see, आज का जो पेपर है वहाँ पे क्या मैटर करेगा is your presentation skills. इतना आसान पेपर. फाइन. सेक्शन ए में से कोई भी 2 क्वेश्चन उठाओ. वैसे had I been in your place, I would have taken question number 2 जिसमें there is plate tectonics. I would have taken Thornwright वाला question and I would have taken isodopants वाला question because that is core geography. Fine. There are 3 questions in which core geography is asked. सेक्शन बी में से भी 2 क्वेश्चन उठा सकते हो, आइसोडोपेन वाला या ग्रोथ पोल थियरी वाला. इतना डायरेक्ट क्वेश्चंस हैव बीन आस्क्ड. बट व्हाट विल मैटर इज द प्रेजेंटेशन, व्हाट विल मैटर इज द एग्जांपल्स. पेपर जब टफ आता है तो व्हाट मैटर्स इज नॉलेज. वेरी फ्यू पीपल हैव नॉलेज, बट इतना जब इजी पेपर आता है देन व्हाट मैटर्स इज द प्रेजेंटेशन स्किल्स, योर डायग्राम ड्राइंग स्किल्स. एवरीवन विल ड्रॉ द 3 टाइप्स ऑफ प्लेट बाउंड्रीज, बट who will give the example of circum-Pacific belt, who can give the example of mid-continental belt, who can link it with the volcanoes, and who can put the current example of day before yesterday's earthquake in Indonesia. Fine. So that is going to matter in this. So let us have a look at the past year questions very quickly. No need of writing or anything, just you should have an idea कि हम कैसे पढ़ने वाले हैं, so that you will be able to write any answer on this. So I will come to the climatology part first and we will start from the first question of the climatology. So they had asked you regarding the monsoon. In the year 2008, discuss the mechanism. Mechanism पूछा है means what I have told you right now. No theory, mechanism, comma, origin of monsoon winds, and explain the role of El Nino on the monsoon circulation. So you have to write about the mechanism, no theory, and role of monsoon circulation. Then, got that question? Then they had asked you directly in the 2014, discuss the nature and the origin of Indian monsoon. Again the same question. Discuss the nature and the origin of Indian monsoon. The same diagram we have drawn, 2 diagrams. But second part change हो गया. वहाँ पे they had asked you regarding the role of El Nino. Here they are asking you about the recent techniques of the prediction. Fine. Then they have asked you in 2018, explain the origin, progress and the retreat of Indian monsoon. First part is same, second part फिर से change हो गया, discuss उसका impact in the Indian economy. So can you see the first part is more or less the same. Come now to Indian geography. Remember, these are bouncer questions. Actually monsoon is where? In Indian geography. So come to the chapter 1, paper 2. And you will get variety of questions here. Analyze the mechanism of Indian monsoon. Again the first part is same. How are the spatial temporal variations and the vicissitudes in the precipitation related to this mechanism? That is why there is variation in the monsoon. Direct question, why there is shape of India, size of India, El Nino, La Lina, etc. Got it? 87 ka question. Physical settings, not given. Mila? Question number 9. This is specific question. Explain some of the important theories. यहाँ पे specifically पूछा है theories. In the origin of southwest monsoon in India, evaluate the impact of its characteristics with occurrence of floods and droughts in the different part of country. Means variation क्यों है? But the first part has changed in the first question. अभी तक first part has more or less remained same. यहाँ पे they have asked you about the theories. Question number 12, 92. Discuss the major characteristics of Indian monsoon with special emphasis on the causative factors. What are the factors affecting Indian monsoon? Himalayas, jet streams, etc. This is. 94. Explain the recent theories put forward into the to explain the origin and mechanism of Indian monsoon. Can you find out the difference between the question of 90 and 94? 90 में they have asked you some theories, important theories. यहाँ पे they are asking you about the recent theories. Keyword देखो, you are not supposed to write all the theories. You are supposed to write only the recent theories. That are two recent theories, jet stream theory and the heating of Tibetan plateau की theory. Question number 95. Explain the factors responsible for uneven distribution of rainfall in India. Next page means here. 99. Elucidate the mechanism of Indian monsoon. 2002. Explain the origin, mechanism and characteristics of summer monsoon in India. Means explain the origin, characteristics of southwest monsoon, not the northeast monsoon. 2004. Discuss the role of spatial pattern of rainfall and temperature in delimitation of climatic regions of India, especially with reference to the Stamp's climatic regional classification. Thornwhite, Köppen and Stamp are the three thinkers in climatology. They are yet to come to them, and they have classified it on the basis of the monsoon amount of rainfall. So it is an indirect question from monsoon. Give a critical account, 2006, on the recent theories of origin of monsoon with special reference to the jet stream theory. Give a reason as to why variable, 2009, rainfall variability is the characteristic feature of India's monsoon. Now, June batch students, you know variation, mean deviation upon the standard upon average. तो वही लिखना है, why it is there, what are the factors. फिर से 13 में डिस्कस द मैकेनिज्म ऑफ इंडियन मॉनसून. 2015 में एक्सप्लेन द पैटर्न ऑफ विंटर रेनफॉल इन इंडिया, दैट इज द नॉर्थ ईस्ट मॉनसून, वेस्टर्न डिस्टर्बेंसेस. 2017 में current affairs based question, give a recent account of unusual pattern of distribution of monsoon rainfall in India in 2017. Obviously this question is not going to come again. Had आज आ सकता है आज के पेपर में, I don't know the paper, कि uneven distribution, unusual pattern. There is so heavy rainfall right now also. Yesterday there was a, day before yesterday there was a heavy rainfall and a thunderstorm in UP. This is very unusual pattern. Fine. So these are the questions of Indian monsoon. So getting an idea how you should study, the focus is on mechanism, second focus is on the theories, recent theories, and third focus is on the variation, that is the factors affecting monsoon. कभी कभी current based questions आते हैं regarding this thing. Fine. So the point number 1 is अब देखो थियरी, फ्लॉन की थियरी, इक्वेटोरियल वेस्टर्लीज कैंसल्ड, ये है पुरानी थियरी. न्यू थियरी इज कोटेश्वरम की थियरी. सो monsoon, monsoon type of a climate, monsoon type of a climate means I will do paper 2 का climate also right now only. Monsoon type of a climate is characterized by reversal in the winds, complete reversal in the wind direction, is characterized by complete reversal in the wind direction, bracket complete reversal means 180 degree change in the wind direction, complete reversal in the wind direction. Next, according to LD stamp, India is par excellence a tropical monsoon country. India is par excellence, the best example of tropical monsoon country. Though geographically the country is situated in both tropical and temperate belt. Tropical and temperate belt. Marsden. Choice is yours. मेरा काम है thinkers देना. Choice is yours. How much you remember, how much you don't remember. Marsden stamp you should remember. Dudley stamp. Marsden believed that India possesses all the types of climate. India possesses all the types of climate. But this climatic diversities have one unifying factor, that is the monsoon. Have one unifying factor, that is the monsoon. one unifying factor, that is the monsoon. Tell me with examples ये statement का meaning Marsden के. What is the meaning of this statement? We have one type of climate, that is monsoon type of climate. When do we get rainfall? Except for Tamilians, when do we get rainfall? Summers, that is June to September. We get rainfall. Is the rainfall same throughout the country? No. It can be greater than 250 centimeters in some part. It can be only 15 centimeters in some part. 250 centimeters में जहाँ पे rainfall is greater, it is known as evergreen tropical, evergreen type of climate. It is जहाँ पे 15 centimeters से कम है rainfall, वहाँ पे the climate is known as desert type of climate. In India, we call both the climate as monsoon type of climate. Understanding? Cherrapunji receives more than 1100 centimeters of rainfall in a single year, and Jaisalmer receives around 20 centimeters of rainfall in a year. एक ही climatic pattern में. Western extreme, that is Leh Ladakh has, or Kargil has less than 40 degrees Celsius of temperature, and Jaisalmer has more than 52 degrees Celsius of temperature. Tundra and tropical hot desert. The same type of climate may, there is no winters in this part, there is no winters in this part, there is no winters in this part, but the winters and summers are very severe in this part. Why? Distance from the sea. So this is what is the variation, and this was the first, that is why I had asked you to go through the question. Was there a question that is the variations in the climate is one of the chief features? So why these variations are there? Then you can start your statement with Marsden. Marsden ने कहा था ऐसे. You can give the examples of the variations, and these variations are due to numerous factors. So no कौन सा thinker कहाँ use करना है. Variations पे question आया, climatic factors पे question आया, factors affecting monsoon पे question आया, तो start with Marsden. हमारा one unifying factor is monsoon. हमारा one unifying factor in physical geography is Himalayas. Fine? Himalayas is not just a physical barrier, it is a cultural barrier also. Understanding? And हमारा one unifying factor is the monsoon. Whether you belong to any religion, whether you belong to any caste, whether you belong to any part of the country, you all are awaiting the Indian monsoon, because उससे पहले summer dries up the country. Getting it? There is high amount of heat. So हर कोई राह देखता है कि कब monsoon आएगा. Understanding? Nowhere in the world people anticipate rain with such a great extent कि उसके ऊपर movies बनती है. That is only in the monsoon type of climate, because nowhere in the world the initial 3 months are so dry that not a drop of water is left, and the temperature becomes 40-45 degrees Celsius. बाकी के regions में क्या है, temperature थोड़ा भी बढ़ गया, साइबेरिया में 28 का 32 डिग्री हो गया तो convectional current शुरू हो जाता है, and it gives rainfall in the evening. इक्वेटर में टेम्परेचर थोड़ा बढ़ गया, शाम में बारिश होने वाली है, उनको पता है. अंडरस्टैंडिंग दिस? सहारा में टेम्परेचर कितना भी बढ़ने दो, कुछ नहीं होने वाला. दे नो दिस. सो बट इट इज द monsoon type of climate. That is why it is so important in the geography also, the studies of the monsoon, and there are so many theories. Next point, the variations are as given below. 1, the northern India experiences four seasons in a year. There is winter, there is summer, there is spring, there is autumn, right? Peninsular India, Andhra mein how many seasons? You are from Andhra, right? How many seasons? Which are the 2 seasons? Summer and rainy season. See, summer, matlab Andhra mein, peninsular India mein, there is only one season, dry summer season and wet summer season. There is no winter. This is one variation, right? While the coastal regions of the peninsular India, same point. While the coastal regions of the peninsular India have hot and humid climate throughout the year. Have hot and humid climate throughout the year. Next point. The daytime temperatures in the month of June can be as high as 50 degrees Celsius in northwest, How much is the daytime temperature in June in Mumbai? Can be around 35 degrees Celsius in coastal peninsula, comma, can be around 35 degrees Celsius in coastal peninsula. And can be as low as 10 degrees Celsius in Kashmir. Can be as low as 10 degrees Celsius in Kashmir. Dividing India into क्या दिखाता है ये? Tropical 35 degrees Celsius, right? Dividing India into tropical, subtropical and temperate belt. Third example. In December, the night time temperature, देखो, we are taking the extremes. So June में you are comparing daytime temperatures. December में you should compare night time temperatures. In December, the night time temperatures is around minus 40 degrees Celsius, which is the coolest place in India. Dras, Kargil. This is the coolest place in India. Is around minus 40 degrees Celsius in Dras or Kargil. While it is 28 degrees Celsius, in Thiruvananthapuram या कोचीन लिख लो, चलो थिरुवनंतपुरम नहीं, कोची, in Kochi. Next. The variation is also seen in the arrival and the withdrawal of Indian monsoon. In the arrival and withdrawal of Indian monsoon. Malabar coast, the Malabar coast experiences onset of monsoon, on 1st of June, while the northwestern India. When does monsoon arrive in Delhi? कब हुई बारिश इस टाइम मानसून? जुलाई और जून? July. The northwestern India experiences arrival of monsoon on around 15th of July. See, this lines what I have drawn is an example of iso height, lines joining the places of equal rainfall. This is a diagram regarding the arrival of monsoon. All the places in between first this line will see the arrival of monsoon on 1st June. Mumbai, interior parts, भुवनेश्वर से थोड़ा ऊपर जाके 10th of June, 15th of June. In the same point, fine, but after the diagram. Similarly, the monsoon starts withdrawing initially from northwest India by 1st of September, while it withdraws from Kerala, on 1st of December. Withdraws from Kerala on 1st of December. ऐसा नहीं है कि इससे पहले तारीख को ही जाता है. 15 September की भी लाइन है, but I am not making you draw this. So you can see how late it arrives in northwest, 15 July, and how early it withdraws. How early it arrives, 1st of June, and how late it withdraws. Sorry. 15th of December. So is it, now looking at the proper diagram, are you surprised कि यूपी में अभी भी बारिश हो सकती है? होगी. ईस्टर्न यूपी में अभी भी बारिश है. It has not yet withdrawn. This is the standard diagram from last 100 years का data. Monsoon withdraws from all this region from 1st of October. This is how the retreating monsoon is going away. This is onset, this is withdrawal of monsoon. And the last point, The monsoon rainfall of India is highly variable. The monsoon rainfall of India is highly variable. Some regions have variability of less than 15%, while some regions have more than 40% of variability. More than 40% of variability. Example, the regions of low rainfall are characterized by very high variability. The regions of low rainfall are characterized by very high variability. That is the northwest India, while the regions of heavy rainfall have the variability less than 15%. While the rest of India has variability of around 15 to 35%. Rest of India have variability of around 15 to 35%. So the regions which are having very less rainfall will always have greater variability. So there is an equation, we will do it later on, which is known as the coefficient of variation of Indian monsoon is given upon by standard deviation upon average, that is mean, expressed as percentage. So if the average rainfall of this region is around 100 centimeters, but हुआ उस साल सिर्फ 20 centimeter of rain, so how much deviation is there? 80 is the deviation, 80 centimeters. Average होना चाहिए था 100%, हुआ 100 centimeters, होना चाहिए था, हुआ only 20 centimeters. So कितना नहीं हुआ? 80. So कितना deviation है? 80% deviation. This is what is the standard deviation. No need of writing this, I will explain it to you separately. So remember for prelims, कहाँ पे सबसे ज़्यादा deviation है और कहाँ पे सबसे कम deviation है. Deviation means जहाँ पे कम chances है rainfall के, the drought prone regions of India. कहाँ पे सबसे कम है deviation? जहाँ 100% rain is going to come. Coastal regions of west coast, southwest monsoon and northeast India. Fine. Show me your map of India. How you drew the map of India? I have seen in Charoka. How is your map of India coming out? Show it. Practice it very properly. Baki, yours are fine. You need to practice it. You need to make it bit smaller. जितना छोटा बनाओगे उतना it will be less prone to errors. Just make sure that ये make a straight line from here. Mistake happens when you try to take this and this in the same point. It is slightly to the right. Gujarat ka this part and the Mizoram are more or less in the same line. Then the mistake does not happen. Variability. Arunachal has more than 400 centimeters of rainfall. इसलिए तो Namdapha Biosphere Reserve has tropical evergreen forest. The only national park in India which has tropical to tundra vegetation is Arunachal. Arunachal is the only state जहाँ पे 400 से ज़्यादा rainfall भी है and Great Himalayas भी है. So वहाँ पे national park, any national park in the Arunachal has tropical evergreen at the foothills, and at the top, due to Great Himalayas, it has tundra vegetation. Remember this. Generally, we think Arunachal does not get rainfall more than 400 centimeters along the foothills. Why? Because Garo Khasi Jayantia, uske baad there is a gap. Then there is Brahmaputra, rain, forest, enough source of potential evapotranspiration and moisture, and therefore after that winds are forced to rise up orographically. If they are forced to rise up orographically and give heavy rainfall in this latitude, imagine they are covering a shorter distance. यहाँ तक तो they are full of moisture. यहाँ पे there is no moisture. Still along the foothills, उत्तराखंड में अगर बारिश हो सकती है इतनी, Arunachal is much at lower latitudes, and winds are full of moisture. Bangladesh तक they are full of moisture. Arunachal में orographic rainfall is very heavy. Sikkim में it is less, but Arunachal में it is very heavy. That is why Sikkim comes, Assam comes in 30 to 35%. So these are the variations in the Indian climate. Why? Tell me. Because of different factors. So can I say one factor that causes variation in the climate of India is the size and the extent of India? So the first factor is location. Comma, longitudinal. had India not been in such a position that the Tropic of Cancer would have cut India into two parts, India would have got only one type of climate. But India is located in such a great latitudinal extent, we have this part at 8° north, means equatorial type of climate, subtropical type of climate, temperate type of climate. That is the latitudinal extent. Longitudinal extent, more or less equivalent, and therefore, because of the longitudinal extent, some parts are very near to the sea, coastal climate, maritime climate, some parts are having extreme type of climate because they are very far away from the sea. Getting it? So, first, the mainland India extends to around 30° in both latitudes and longitudes. With Tropic of Cancer dividing India into two parts. And hence, some parts of India are located in tropical zone of hot and humid climate throughout the year. Some part in the warm temperate zone, and some part in the alpine zone. No need of drawing this, but have a general understanding. Blue color ka line is the alpine zone. Yahan pe the temperature is always less than 18°C at the height of 3,500 meters in the Himalayas. Wahan se alpine zone, 3,000 to 3,500 meters in the Himalayas. Central part is the warm temperate zone, and the lower ka part is the tropical zone. That is why biodiversity in India is so high. And can you see, Northeast India ऐसा region है जहाँ पे all the three junctions are there, and therefore Northeast India has the highest biodiversity because of the junction of different biogeographic zones. One of the favorite question of UPSC in prelims is biodiversity is high in Northeast India. एक option देते हैं because of heavy rainfall and high temperature. एक option होता है because it is located at a junction of different biogeographic zones. So what is the perfect answer? Different biogeographic zones. Different biogeographic zones है इसलिए climate अलग है. Getting it? Second factor, distance from the sea. This creates difference in the continental or extreme climate and maritime climate. This creates a difference between continental or extreme climate and maritime or moderate climate. huge water bodies such as Arabian Sea and Bay of Bengal. Huge water bodies such as Arabian Sea and Bay of Bengal. Moderate the sea surface temperature, moderate the temperatures in peninsula, and hence the peninsula does not experience, winter season. While the annual range of temperature is very high, in north due to continentality. Annual range of temperature is very high in north due to continentality. Third factor is Himalayas. I will not dictate the Himalayas. First we will understand the Himalayas, then खुद आपको पता होना चाहिए कैसे आंसर लिखना है due to the Himalayas. सबसे पहली बात, had Himalayas not been there, then during the winter season, this is a trade wind belt, cold wind would have come to India and it would have reduced the temperatures in this region. During the summer season, the southwest monsoon winds would not have been stopped by the Himalayas. So during the summers, India would have been a dry and hot desert. And during the winters, India would have been a cold desert. This is one general understanding you all have. Had there been no Himalayas. But more importantly, had there been no Himalayas, this region would not have been then that extreme during the summer. See, imagine the cold winds coming and giving huge amount of snowfall, and this region being covered by snow. So when the summers would have set in, the first work of the summers would have been to melt the snow, right? Had there been melting of the snow, तो heat इतनी ज़्यादा बढ़ती नहीं. Had there been no heat, ITCZ would not have shifted to India. अगर ITCZ shift नहीं होता इंडिया में, तो ये इंडिया लो प्रेशर बेल्ट नहीं होता. Low pressure belt, had it not been formed, there would not been no equatorial westerlies or southwest monsoon winds. ये points आने दो सबसे पहले. So point number 1 is you can mention about Himalayas stop cold winds during winters, and therefore India experiences comparatively, more important is comparatively, warmer winters. Second point is Himalayas acts as a barrier stopping rain bearing southwest monsoon winds and therefore India gets rainfall third point is shifting of monsoon trough, which is nothing but ITCZ, favors development of low pressure center over India, attracting, अब रेन बियरिंग वर्ड यूज किया है, सो मॉइस्ट ट्रेड्स मतलब ट्रेड विंड्स फ्रॉम southern hemisphere as south west monsoon winds. Is there any doubt in these 3 points? Then only I will progress. The third statement means this entire landmass, especially the Himalayas, become so hot that we say that ITCZ has shifted to the north. Matlab, this is more hotter than equator, and therefore this becomes a low pressure belt. As this becomes a low pressure belt, sun is over the Tropic of Cancer, which is here in the month of June, right? Therefore, the other extreme, that is the Tropic of Capricorn, experiences winters. That means this is at a comparatively high pressure belt. Winds start from here, high pressure belt of southern hemisphere. They come to the equator, and after crossing the equator, they come towards India as southwest monsoon. Had there been no Himalayas, itna extreme climate nahi hota, ITCZ would not have shifted. And ITCZ kahin to fir South India mein hota, and North India would have been a desert. Understanding? It is because the ITCZ is there, therefore the winds are attracted always towards the ITCZ. Trade winds will always come towards the ITCZ. Trade winds from the northern hemisphere also come at the ITCZ. The trade winds from the southern hemisphere also come as the ITCZ. We are not concerned about the trade winds from the northern hemisphere. We are concerned about this winds, जिसको हम कहते हैं as the southwest monsoon winds. Getting it? This is the meaning of the statement. ITCZ वहाँ पे इसलिए कोल्ड विंड्स आके नहीं, हाई प्रेशर नहीं होता, नॉर्मल कंडीशंस होती, बट ये ट्रेड विंड्स कहाँ से आ रही है, कॉन्टिनेंट से आ रही है, सो दे आर ड्राई विंड्स। ड्राई विंड्स होता है इसलिए वो रेनफॉल नहीं देते, बिकॉज दिस आर कमिंग फ्रॉम ओशंस, देयरफॉर दे आर मॉइस्ट विंड्स एंड दे गिव द रेनफॉल। व्हाई दे गिव द रेनफॉल? पॉइंट नंबर 2. व्हाई दे कम? पॉइंट नंबर 3. Clear? Everyone? Fourth, in the Himalayas only. Himalayas act as an effective barrier Himalayas act as an effective barrier and therefore in the winter season it causes bifurcation of subtropical westerly jet stream this jet stream which originates in the Mediterranean Sea Caspian Sea region, this jet stream which originates in the Mediterranean Sea Caspian Sea region is responsible for western disturbances in India. Is responsible for western disturbances in India. In India, western disturbances are what? Winter rainfall, जिसके ऊपर वो क्वेश्चन था. सी नाउ अगेन ये एक एक पॉइंट डिटेल में बाद में आएगा, बट दिस इज क्वेश्चन रिगार्डिंग द इम्पोर्टेंस ऑफ द हिमालयस. सो द यहाँ से द जेट स्ट्रीम इज फ्लोइंग. एज द जेट स्ट्रीम इज फ्लोइंग इट इज टेकिंग द सरफेस विंड्स अलॉन्ग विद इट. द सरफेस विंड्स बिकॉज दे आर कमिंग फ्रॉम द सी दे आर मॉइस्ट, बट व्हेन दे कम टू इंडिया दैट इज ड्यू टू द हिमालयस, this jet stream which should go straight, it is bifurcated by the Himalayas. So it is divided into two branches. एक जाता है नॉर्थ में, एक जाता है साउथ में. जो साउथ में है it gives rainfall, जो नॉर्थ में है it gives snowfall. Getting it? Because of the snowfall, we say Himalayan rivers are having water throughout the year, that is they are perennial. Imagine had there been no western disturbances, no Himalayas, no question of perennial flow. Why perennial? Because during the summer season when Godavari jaisi mighty river becomes dry, the North India ka rivers get moisture or water from melting of the snow. But kahan se aa raha hai ye snow? It is coming due to western disturbances. Why there is a rainfall even in winter season jab evaporation nahi hai? Because relative humidity is inversely proportional to temperature. So even whatever the amount of moisture hai, it is enough to give the rainfall, as the holding capacity of the air in the winter is very less. Plus Himalayas force the jet streams to rise upwards. Had there been no Himalayas, ये red color की wind flows at the height of 6 kilometers from the ground. उसको कोई फर्क ही नहीं पड़ता. It would have bypassed the entire India. Getting it? It is because of the Himalayas this wind is blocked. Fine? Getting it? This western disturbances are responsible for perennial flow of Himalayan rivers, as well as for Rabi cropping pattern in North India. Now understand, when the sun will come to the southern hemisphere, northern hemisphere, ITCZ आएगा, क्या गायब हो जाएगा? The southern branch of the westerly jet stream. This goes. Now which is there? Only the northern branch of the westerly jet stream, which is flowing over Tibetan plateau. Ab Tibetan plateau is the highest plateau in the world, which is at a height of 5 kilometers to 5.5 kilometers. Fine, very simple understanding. The westerly jet stream which is flowing here, for a person who is staying at a lower height, उसके लिए तो वो jet stream है. But for a person who is staying in the Tibetan plateau, उसके लिए तो surface wind है. For him it is more like a surface wind. Jet stream is coming towards the surface Tibetan plateau, is getting heated. Why? Because Tibetan plateau being at the height receives 2% more insolation as compared to the surrounding regions, because it is at a greater height, and it gets heated also very fast. Snow melts also very fast. Distance कम हो जाता है insolation का, therefore losses become less. As a result of this, the westerly jet stream जो बची हुई है during the summers, this is the ITCZ, this is where the sun is, remember, it gets heated, and any air after getting heated will rise upwards. Any air after rising upwards, it is bifurcated into two branches, एक equator की तरफ, एक poles की तरफ. The one which starts flowing towards the equator, यहाँ से पूरा heat हो रहा है, remember, one which starts flowing towards the equator, it becomes geostrophic in nature, as it is going to get deflected to the right hand side in the northern hemisphere. So ऐसे flow करेगी, so it flows this way, फिर it will go and it will settle over Madagascar region, and therefore at the Madagascar there will be high pressure, because ऊपर से wind नीचे हो जाएगी, and once the high pressure is formed at the Madagascar, surface wind always flows from high pressure to low pressure as southwest monsoon winds. So ये जो blue color की wind है which flows on the surface, understanding this, this is what is known as Somali current or Somali jet. Understanding? This is what is known as a Somali jet stream. So what is happening? Due to the heating of the Tibetan plateau, it is rising up, it is bifurcating, it is moving to the right, ultimately it is going and settling over the Horn of Africa, जिसको हम कहेंगे Mascarenes High or Madagascar High. Once it settles there, this entire branch starts coming towards India as the southwest monsoon. कहाँ से आ रहा है? From the Somalia region, and we'll call this as the Somali stream, Somali current. So had there been no Himalayas, ये पूरा region ही नहीं होता. अगर ये jet streams नहीं होती, तो अरे Bay of Bengal branch अंदर की तरफ नहीं आता. Getting it? Had there been no Madagascar high, तो ये stream ही नहीं होती. Monsoons would have become weak. So it is the Tibetan plateau which makes the monsoon strong. In fact, NCERT mein, if you read that chapter, there is a line written, lesser the snow over the Tibetan plateau, stronger is the monsoon. Lesser the snow means more heating, more air rising upwards, more air rising upwards, more air going and settling over the Madagascar region. Understanding? Everyone? Clear? Southwest monsoon is a surface wind. Yes, but at a height. बस यही फर्क है. सरफेस विंड को हम साउथ वेस्ट मानसून कहेंगे. सब सरफेस विंड, अपर एयर सर्कुलेशन को हम जेट स्ट्रीम कहेंगे. सो जेट स्ट्रीम दो टाइप के, ईस्टर्ली जेट स्ट्रीम एंड और जो मैडागास्कर के ऊपर से भी जाएगी वो सोमाली जेट स्ट्रीम. वो समझ में आएगा थोड़ा, बट दोनों अलग अलग है. बस क्या फर्क है? सरफेस एंड अबव द सरफेस. फाइन. सो नेक्स्ट, टिबेटियन प्लाटू मतलब हिमालयाज में ही पार्ट में आएगा ये. The heating of the Tibetan plateau, the heating of the Tibetan plateau is responsible for the stronger monsoon. ब्रैकेट में लिखना P. Koteshwaram. It was the role of Tibetan plateau was given by Koteshwaram की theory. Due to the heating of the Tibetan plateau, anticyclonic circulation develops in upper tropopause over Tibet. Why I am saying anticyclonic circulation? Because you see, ये ऊपर जाके it is getting bifurcated. So जो भी bifurcate होता है, we will call this as a anticyclone. Cyclone is convergence, anticyclonic is divergence. In the upper troposphere, the southern branch of this upper air circulation becomes easterly jet stream which helps in formation of Mascarini high or Madagascar high, Madagascar high, intensifying the southwest monsoon winds. अभी हम सोमाली नहीं लिखेंगे इसमें. Intensifying the southwest monsoon winds. Intensifying the southwest monsoon winds. Understood this point? See, this is what. Monsoon trough is the heat source, low pressure. Air is going up. It is going and settling over Madagascar. And then it is flowing as the surface air. उसी को हम कहेंगे easterly, tropical easterly jet also. This is a proper diagram. Fine. Getting it? And you can draw this diagram. Why Madagascar high? Because of the high pressure over Madagascar. Why it is known as upper air anticyclone? This is India, Peninsular Plateau, Great Plains and Himalayas. 3 ranges of the Himalayas, Great, Middle and Shivaliks. Clear? So take down the question. ऊपर वाली, हाँ. Surface winds. Which sir said? While coming to India, it is the southwest monsoon wind. But why Madagascar say it will come to India? Because of high pressure over Madagascar. Don't confuse अभी सोमाली इसमें. सोमाली अलग कंसेप्ट है, इसलिए मैंने लिखा है नहीं. अगर इसमें सोमाली डालोगे तो कंफ्यूज हो जाओगे. Surface winds is the just a minute. Lecture में देगा. Okay. यहाँ तक समझ में आया? While after coming, ये जो रेड लाइन है, that is southwest monsoon. सोमाली अब भूल जाओ, सोमाली यहाँ पे है कहीं तो. वो मैंने दिया नहीं है, फिर उससे कंफ्यूजन होगा. सोमाली एक अलग पैरामीटर है. सोमाली इसलिए नहीं because it does not play that important role in Indian monsoon. It is the So take the question. Examine the role of Himalayas in Indian monsoon. मतलब anything regarding the Himalayas. Examine the role of Himalayas in Indian monsoon. Second question. Explain how the Tibetan plateau plays an important role in the development, intensity of monsoon rainfall over Asia. Of monsoon rainfall over Asia. Don't worry about the second question, you won't be able to write it because second question is Koteshwaram ki theory. But in short, this is Koteshwaram ki theory. Right? This is what is the Koteshwaram ki theory. So Koteshwaram ka naam isliye you should know because he gave the concept of easterly jet stream. 1952 में. Fourth factor of Indian monsoon, why there are so many variations. The fourth factor is physiography. You can see there is so much variation in the physiography. Plateau है, कुछ plain है, plateaus पे भी western ghats है, Aravalis है, Vindhyas है, Satpuras है. There are so many variations. So because of the variations in the physiography, will there be variation in the heating and cooling? Will it cause variation in the pressure conditions? And therefore pressure conditions will change the direction of the winds. Getting it? So physiography determines the atmospheric pressure, wind direction, atmospheric pressure, wind direction, and the amount of rainfall. In fact, the physical map of India is closely related to the climatic map of India. It's closely related to the climatic map of India. Point number 1 इसमें how it is. So first point is the shape of the peninsula. The shape of the peninsula causes bifurcation of southwest monsoon winds into two branches. कौन से two branches? The Bay of Bengal branch and Arabian Sea branch. No need of this diagram. Into two branches, the Bay of Bengal branch and the Arabian Sea branch. Right? Now look at this diagram. Going to show you, no need of making this. Western Ghats, very heavy rainfall. रुक गई ये line. Going inside because this is the rift valley between Vindhyas and Satpuras. Therefore, it is going inside the rift valley, getting trapped there. And यहाँ पे there is a very heavy rainfall. Then you know river Narmada originates here, river Son originates here. River Mahanadi, river Damodar, river Mahanadi. Radial drainage pattern in India. ये straight गया because यहाँ पे Aravalis है. And जाके it gives heavy rainfall to the Uttarakhand, famous for landslides in India. It is not going this way because orographic rainfall के लिए we have done that mountain should be perpendicular to the wind direction, not parallel. Aravalis is parallel, therefore it is bypassing the Aravalis. Therefore, this entire part is a desert. Because this is a desert, it becomes so hot that it develops a low pressure. And this Bay of Bengal branch, it is stopped by the Himalayas, Arakan Yoma mountains. It gets bifurcated here, goes and strikes northeast, and then after coming here, it gets attracted towards the low pressure. You can see how they are turning inside. So that is why the physiography of India. Getting it? कहाँ से कैसे winds are going. Understood? Why the Bay of Bengal branch is turning inside? Because it is getting attracted towards the high heat of northwest India. The thermal low pressure is developed in the northwest of India. Pura India has monsoon except northwest India. We have just seen 15 July tak. June mein most of the India has monsoon. So northwest India does not have monsoon. So July mein it is still very hot and therefore it comes towards. And then अंदर आते आते rainfall धीरे धीरे कम होता है till the time it reaches Delhi. Most of the moisture is lost again फिर से Rajasthan is a desert. Getting it? Jaipur is same like Delhi. Jaipur का climate is same like Delhi का climate. Desert in India is present only in the western Rajasthan, west of the Aravallis. इसको तो कहते हैं semi desert. Desert in India is Marusthali. Semi desert in India in Rajasthan is Marwar region. इसलिए मारवाड़ीज जो मारवाड़ से आते हैं, अंडरस्टैंडिंग? That is a semi-desert region. They come from Marwar upland, not from Marustali region. Marustali मतलब desert. Next. Very heavy rainfall in India. Very heavy rainfall in India. Occurs in the regions where the southwest monsoon winds hit perpendicularly to the mountain ranges. While the rain shadow regions of these mountains are either drought prone or deserts. Rain shadow regions of these mountains are either drought prone or deserts. And you can draw this diagram now. Blue color lines you understand they are the heavy rainfall wala rains. Now you can see in the diagram, the amount of rainfall in India goes on decreasing from Kolkata to Jaipur, Kolkata to Delhi. Why? Because distance from the sea increases. वैसे बे ऑफ बंगाल ब्रांच अंदर अंदर जाएगा, it does not have any new source of moisture, therefore rainfall goes on decreasing. ये क्यों है? Drought prone because the wind is forced to come down from the Western Ghat. Clear? So after the diagram, in fact the physiography determines the behavior of monsoon winds, The Bay of Bengal branch gives less rainfall as it progresses inside the plains. Gives less rainfall as it progresses inside the plains due to increase in the distance from the sea. Due to increase in the distance from the sea. Next factor, upper air circulation or the jet streams. Not much important in optional जितना it is important in GS. जितना optional में आप लिख पाओगे, I am just giving you in short. That is, it is सबसे पहले westerly jet stream, क्योंकि हमें ये टॉपिक अलग से पढ़ना है. Therefore, we should just have a brief idea for monsoon. Remember, monsoon does not mean rainfall, it means climate. So India has a monsoon type of climate, जहाँ पे there is a seasonal reversal of wind is occurring. So westerly jet stream will come in winters in India. It flows from west to east. It gives winter rainfall in India. Known as western disturbances. Why it gives the rainfall? Because it brings moisture, depending upon how the question is asked, or from the Mediterranean Caspian region. Clear? So उनको हम कहेंगे even as the temperate cyclones. Temperate cyclones are nothing but then there is easterly jet stream. Temperate cyclones. Orography तो खत्म हो गया, ये नया फैक्टर है upper air circulation. So western disturbance is nothing but temperate cyclone. You will understand this in the coming lectures. Q. Or it is also known as ट्रॉपिकल ईस्टर्ली जेट, जिसको शॉर्ट फॉर्म में लिखा जाता है तेज. It develops in summers over India. You already know why, due to heating of any wind that is flowing at an upper height is known as jet stream. So it is due to heating of Tibetan plateau. What it does, it causes sudden onset of monsoon. Which monsoon? Of southwest monsoon over India. बस इतनी दो चीजें ध्यान में रखो. Looking at the diagram, same latitudes में है, मेडिटेरेनियन सी, कैस्पियन सी, ब्लैक सी, वहाँ से मॉइस्चर लेके इंडिया में. पाकिस्तान में भी होगी, ईरान में भी होगी. It has nothing to do with orography. यही जेट स्ट्रीम है जो विंटर्स आते ही अब आना शुरू हो गई है इंडिया में. यही जेट स्ट्रीम है जो सारा पोल्यूशन लेके आती है ओवर दिल्ली. Temperate. India is also temperate. The part of India where we are is temperate. You will understand in Indian geography why we call it as a subtropical. Not because climate, because there are numerous factors including cultural factors. Next factor, अलग क्वेश्चन ही, सदर्न ऑसिलेशन, अल नीनो, ला नीना. You already know El Nino, droughts, La Nina, rainfall. इंडियन ओशन डाइपोल, सब अलग टॉपिक से, इसलिए अभी मैं कुछ नहीं लिखा रहा हूँ. एंड लास्ट, so I'll stop here. Tomorrow's lecture is going to be very, very crucial. All the theories of Indian monsoon. Fine. Paper 1 ही नहीं, paper 2 also. I'll give you the test paper. You solve it at home tomorrow. मेरे को टाइम नहीं मिला बनाने को.